what we want to do is fill in what these things mean. So when I'm saying sample space, what am I talking about? If I'm saying event, what am I talking about? If I'm saying complement, what am I talking about? Okay. So we're going to choose the sample space of the people of the classroom. Okay. So if I look at students in the classroom, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So essentially my sample space is going to consist of 16 students. Okay. So if I say I'm looking for everyone, then my answer is always going to be 16. Okay. My chance process is, I'm going to say my chance process. So what I'm looking for is mask color. And specifically, I want to know how many people are wearing black masks today. So raise your hand if your mask is black. There are 5 students in this classroom right now who have black masks on, okay? The complement is essentially not. So if 5 people have black masks, how many people do not have black masks? 11. And how do we know it's 11? Okay. So essentially this is an example of it's either or. Either you have on a black mask or you don't have on a black mask, okay? So complement is everything except for, okay? My sample space by possible outcomes is the students of the classroom. My event is what's happening. So my event is my choice. So event is what I want to have happen. And then the subset is essentially how many people have that particular condition, all right? All right. So let's do another event. Let's do, again, from our students. And let's make the event that you are wearing a watch. You are wearing a watch somewhere on yourself, somewhere on your person. So how many people in this class have a watch on? 1, 2, 3, 4. 4 people? Okay. So if my event is, okay, 5 people. So if I have a watch, how many people had watches?
I have a watch.
Okay, 6, I guess. 6 people have a watch.
On or out?
They have a watch on their wrist or somewhere. They have a pocket watch or something. Okay. The complement is again not. So if 6 people have a watch, how many people do not have a watch? Okay. Well, I did a squiggle. Okay. All right. So what I want you guys to do right now is to shade in the next 4 sets of what we know. Okay. So what we're looking at, if I look at this, essentially I have some new syntax. So I have some new words, union. A union B means, what am I shading in?
Union.
What is the word I'm looking at?
Or.
I'm looking at this word that says
All.
So A, the circle of A contains what A values are. Circle of B contains B values. Circle where they overlap contains values that are both. Okay? So union means all. Intersection means they have to be in both. Okay? And then basically we're shading this in. So that's what we're doing right now. Okay, so what I should have shaded. If I shade A union B, which is all of A is this circle, and, oh, it is. All of A and all of B, essentially I end up shading the whole entire thing. Where do I shade for the intersection? Okay, the stuff that's A and B, there's both of those. All right, now I have this B complement idea. So B complement. Okay. Notice A intersection B complement is the same thing. The complement of B, basically I'm shading in everything that is not B. What do I shade for everything that's not B? A, but I have to eliminate the part that would be part of B. Okay? On the intersection, so I look at the intersection. Intersection's in the middle, but then what I'm really doing is the complement. So if the intersection's in the middle, then the complement is everything that is not in my middle section. Because that's my intersection, so I'm just highlighting it, but now I'm going to take it out. There we go. Okay. All right, so the next thing we're going to do, okay, so let's fill in some things. So in the middle, birds. Someone else have something they want in the middle? Wings.
And then on B, smallest.
All right, so if songbirds are small, and let's say hawks are, then we can say they're large maybe. Okay, what's another thing I can put for, oops. Okay. Hawks are hunters or predators or carnivores, whatever. And birds, songbirds sing. So A intersection B. What is my values for A intersection B off of my choices that I've got up here? Okay, so that would be the set of birds and wings. All right. A minus B. So everything that's in A that's not in B would only be large and hunter. So essentially everything that's only for hawks and not for songbirds. Okay, the last one. A intersection B is everything in the middle. That's the intersection. So the complement is then what? Everything that's not in the middle. So we have large, hunter, and then also small and sings. Okay? Yours should be based on whatever you wrote down. If you don't want to write everything down on your list, cross it out so you only have 6 things to choose from. But anyway, this is just an example of what it's supposed to do. When you have an actual set of data, you're supposed to list the data elements that go in that choice. Okay? All right. So let's say that our chance process. So I'm going to have a new chance process, and my chance process is going to be, let's see, what am I going to do? I'm going to choose a number. The number, oh, that doesn't even look like number. Number is an odd number. And let's say event B is, it's going to be evenly divisible by 3. Okay, so first question. What am I choosing from? If I was going to list what I'm choosing from, what am I choosing from? Okay, so my sample space, what I'm choosing from, my possible choices, okay? Possible things I can choose from are the numbers 1 to 15. Well, or you can write numbers 1 to 15. I don't care what you write, but you need to write something. All right, then we have A. If event A occurs, if I'm saying I want it to be an odd number, What are the choices for an odd number? What's the set of odd values? You're not sure? Gabe, do you know what the odd numbers are? Out of the set of 1 to 15, which numbers are odd? That's what my event A is.
Like 1, 3, 5, 7, 9, 11, 12, 15.
Okay. And I'd stop there because I'm stopping at 15 for my sample set. Okay. So it's 1, 3, 5, 7, 9 up to 15, and then I stop because I've defined my space of choices as being only 1 through 15. That's what I'm looking at for my choices. Okay, the choices, what would I get for choice B, which is the number that I'm choosing divides by 3. Yeah. Yes, so they would be what numbers out of that set? Okay, I am missing one. Can you tell me which one is missing? 11 is not a multiple of 3. Does someone, yeah.
You're missing
6 and 12. So you did the multiples of 3, but you only did odd multiples of 3. Okay, I think maybe you're choosing out of set A, but you're supposed to be choosing out of original set. Okay, so when I'm choosing set, make sure when you're saying, like they're saying now do B, you're not choosing from what you chose from, you're choosing back against the original. Okay, so I should have 3, 6, 9, 12, and 15. Okay, it doesn't have to be in order, but for me it's easier if I write it in order to make sure I didn't miss anything. Okay, so in A are all the numbers. In A are all the numbers that are odd. This is A. In B are all the numbers that divide by 3. This is B. In the middle, all the numbers that are both. So A union B is the entire set in A or B. So 1, 5, 7, 11, and 13, 3, 9, and 15, 6, and 12. A intersection B would be the set that's just in the middle, 3, 9, 15. Okay, this is A. So next one is, this is A. This is the set that is A. The circle that is A, I just highlighted yellow. All right. Complement of A is essentially, complement of A is basically saying not A. So every value that is not part of A, does someone want to tell me what those numbers are? Okay.
It's everything but A?
Everything but A.
So it would be 3, 6, 9.
Okay, I can't, 3, not 3. 3 is part of A. 3 is an odd number. It's in the middle. Okay, the stuff in the middle is part of A and B, but it is part of A. Okay, it's inside the circle for A. So 3 is not A. It has to be something that I did not basically highlight.
12 and 6.
Okay, so I've got 12, I've got 6. And then if you're being really, really awesome, you also noticed it could be, it's these numbers as well.
Doesn't it say everything in A?
Everything that is not in A. A complement AC. A is the complement of A, which means everything that is not in A. Okay.
Did you just not write down everything just because you didn't want to? Like in the B?
I wrote down everything in B that belongs to B. Where are you stuck?
I just thought, because there's a list of A and a list of B, I just thought you had to write all the B's in the B box.
Okay, all the B's are in the B box. The B box pretty much contains these values, 3, 6, 9, 12, and 15. There's the 6, there's the 12. Guess what? 3, 9, and 15 are part of B, but they're also part of A, which is why they're in the middle. So essentially each number, I've got the numbers 1 through 15, right? I have two choices going on, okay? So choice 1 is odd, choice 2 is multiple of 3 or divides by 3, okay? Every number either belongs to A, to B, to both, or to neither. So every number should only show up once. If you've written down your 3 times, that means at least 2 of those are not supposed to be there, because it only, basically 3 belongs to A, but it also belongs to B, so that's why it's in the middle. Does that make sense?
Why'd you put the extra number?
Because in this case, okay, unlike my question about the beginning where the students and we have the masks and what color is your mask, everyone in this classroom has a mask, right? So it's basically, is your mask black or is your mask not black? And we don't have to consider the fact that maybe there's somebody without a mask, because we all have masks, right? In this case, this is my sample space. This is the numbers I'm choosing from. What numbers am I choosing from? These are the numbers that are the possible numbers, right? 1 to 15. These were chosen. Does that make sense?
Yeah.
These were not chosen, but they were there to be chosen from. So if there's extras, they need to go out and say like, okay, there were some extra numbers that didn't fit either condition. Okay. All right. So A union B complement. A union B complement would then be everything that is not in A or in B, and that would be just the extra set. So A minus B, that's A minus B right there. The set of A, take out the stuff that's part of B. That is going to be 1, 5, 7, 11, and 13. That's it. Not for A minus B. I can't, look, I'm taking out everything, so this is B. If I'm saying A minus B, I can't include anything that's in B, and that's all in B. Okay? All right, does anyone need a minute on this? So this problem is a percentage problem. The numbers, students, the numbers you're given are in percentages, okay? If I'm talking percentages, which I am because there's percent signs, what is the number I use for the total percent? What is my total percent always? Okay, so of the people I've surveyed, if I surveyed 10 people, that's 100%. If I surveyed 900 people, that's 100%. I don't know how many people I surveyed, but essentially all of them together make up 100% of my sample. Okay? I have essentially a TV circle, people who saw this ad on the TV. I have a radio circle, people who heard this ad on the radio. And obviously, over in here is only TV. Over here is only radio. And then in the middle is both. Okay. What is the TV percentage? Okay, so I know that my TV percentage, I'm writing it on top for a reason, okay? 33%. What's my radio percentage? 21%. What's my percentage that when I interviewed them, they said, yes, I saw it on the TV, and yes, I saw it on the radio. Okay, so 10%, okay? 10% saw it both ways, okay? So what I'm looking at here is this total value has to be 33%. what number saw it only on, what percentage actually saw it only on the TV? That's going to add up to 43% total. That's not right. 23. Why 23?
Because it's plus the 10%.
Exactly. Okay, my total TV value has to be 33%, but 10% in the middle.
11%.
Exactly. So radio only is 11%. Why? Because 10 plus 11 is 21. Okay? 23 plus the 10 is 33. No, not on these kind. Because 33% of the people did see it on TV. It's just that some of those people saw it on the TV and heard it on the radio. Okay? All right, so there's two ways to figure out the percentage that we're talking about. So I can take 23, 10, and 11. So the percentages I see, and that adds up to 44%. So my total percentage here is 44%. Or I can take, hey, TV people is 33%. Radio people is 21%. That is actually 54%. Why don't those numbers match? The actual number is 44. What's wrong on this one? Right, I'm including that 10. I mean, essentially what's happening is I'm including this 10% once for this number and again for that number. So 10% is in there twice, okay? So if I want to do it this way, essentially then what I need to do is subtract out I need to subtract out one of the 10%, so I'm not doubling it. And then 44%. Okay, hopefully it's clear that 44% is not 100%. So how many people had better things to do than listen to this ad or watch this ad? How many people were not around when the ad was happening? Is it 66? Okay, I'm hearing 66, I'm hearing 56. Which one's correct? Why? So 56 and 44, if I add them together, I get 100. And that's the number I'm supposed to get for a total percent. Okay, what percent of people only saw this? James, how many people saw it and did nothing else? Okay, Jackson, how many people only heard this and nothing else? Okay, how many percentages of people didn't hear it or see it? 56%. Okay, the last one's a little tricky. How many of my people, what percentage of my survey did not see it? And how did we get 67? So 11% plus the 56%. Okay. All right. So there's that problem completed. All right. And that's essentially with given data how you fill it. That's one way to fill out a Venn diagram with numbers. All right. So that's basically what we need to know how to do.